Hey guys, this is Mrs. Harbin, and this is Advanced Math 2.5. Remember, there wasn't a 2.3, but we've been looking at solving systems of equations, and today we're going to look at all three of these methods combined and talk about when we should use which one. So just as a quick review on your own, go ahead and try to solve this system of equations by each method: graphing, substitution, and by elimination. Pause the video, and when you have your x and y coordinates, come back here to check your work. You should have ended up with x equals 6 and y equals 5. Tell what would happen if we solve this system by elimination. Well, after making our coefficients the same, what we end up with is both variables are eliminated and we get 0 equals 9. This is a false statement. 0 equals 9. Eliminates with variables, result is a false statement. We cannot solve that system of equations. What about this system of equations? What would happen? We would get 0 equals 0. Even though both variables are eliminated, we still have a true statement. Your objective for today is this: you, the student, will choose which method is best for solving equations. Each of the three methods has its advantages and disadvantages, so it's best to be familiar with each of them. That way you can decide which method to use. Since the first equation here is easily solved for x, we can do that first and then use substitution. We've got x equals, we add that 3 to both sides, and then we can plug that into the other equation. X equals 1, plug it in and solve for y, y equals -4. So because we can easily solve for the variable, substitution was our best method to use there. The elimination method should work well here. While we don't have the same coefficient, we do know that 3 and 2 are both factors of 6. And we know that we don't want to graph it because we've got a 31 here. We also know that if we try to use substitution, we're going to end up with some crazy fractions. So elimination should work best. Okay, by multiplying both equations here, we get 6x plus 8y equals 6, and -6x plus 21y equals -93. When we combine this, we get 29y equals -87. Solving for y, we get -3, and when we plug that back into our original equation, one of our original equations, we get that x equals 15 divided by 3, which is 5. So our final solution was 5, -3. Now these equations are both already written in slope-intercept form, and our intercepts are 5 and -3. So nothing too crazy like 31 or 96. So let's go ahead and graph these. When we graph both equations, we can see the point of intersection there. So our solution is -4, -7. So that's a good time to use graphing. Today we looked and reviewed at the three different methods, and we chose a method that was best for solving equations. So when it's easy to solve for one variable, like in our first equation, we want to use substitution. When solving for a variable will give us fractions or all kinds of crazy numbers, we may want to use elimination. And when our equations are already in y equals mx plus b, or we can easily put them into y equals mx plus b and graph them because our intercepts are small, then graphing might be the best method. Now, a caution with graphing: if you're doing graphing on notebook paper and just creating your own graph, it can be pretty imprecise if your lines aren't perfectly straight. So if you're going to use the graphing method, make sure that you do have graph paper so that you can make sure your lines are straight and your intersection is at a definite coordinate. If you guys have any questions about these three methods or when to use which one, make sure you ask during class.